something here, singleton, which is very interesting. So that's the next part of my slide. Something on the chat. Composition, yes. Sayam Tenisa has said. And also Gaurav Kumar. True. Let's go back. Yes, how to use Lucid charts. I'll skip these. I think you people will figure out all these things once you log in. You can, yeah, but do please try creating an UML diagram using Lucid chart. So this is just one example. There are many specialized tools for UML. There was a tool called Argo UML. There's Lucid chart itself. There is a tool called Rational Architect. Yeah, so there are many such tools available, and several books were written. These are the most popular ones: Object-Oriented Analysis and Design with Applications by Grady Book. So Book, Jackson, and Trump are the three people, the main guys. And then you have the Object-Oriented Software Engineering by DCBD. So these are quite popular ones, but I don't expect you to read these through. But if you want to know what all diagrams exist, the entire design philosophy behind each of those diagrams, some examples for all those diagrams, then these are the books that will give you those details. Okay, so once again, I repeat, the art of simplicity is a puzzle of complexity. So life is complex, and our endeavor is to make it simple as we grow older and older and older. So the man's quest to bring simplicity in complexity is by separating problem space from the solution space, and then applying some key principles that helps us to manage complexity. Hierarchy and abstraction were two of them, and we talked about classes and objects which represent hierarchy and abstraction in a nice way in software. And we put all these ideas in a modeling language that's called UML. We saw as an example a class diagram and an object diagram. There are many more diagrams which, when you put together, can describe a software system, right? In a standard way. So you and I go and talk to a customer, and you and I understand UML well, then you and I will come up with very similar UML diagram at the end of the day. So that's the whole point. Any questions so far?
Sir, I have a question.
Yeah.
If there is a class and we can make two objects out of the class with same attribute, can we say that the two objects are same?
Yes, exactly. So for example, there are 10 dogs in my apartment complex, right? Dog is a single class, right? So I can have multiple dogs, dog 1, dog 2, dog 3, dog 4. So all these are instances of objects of the same dog. You can of course create them.
Okay.
Makes sense, right? So in fact, if I go to my dog example, so here, if I run this code, barking will be the output. Who was barking? My dog was barking. I can also create another dog, your dog, right? And your dog can also bark, right? So now this will say barking person. Now two dogs are barking, right? My dog can bark 5 times, your dog can bark 5 times. All sorts of things can be done over here, right? And we can even specialize the dogs. For example, I can say a new class, let's say German Shepherd, right? And this extends dog. So German Shepherd is, so it's a hierarchy now. So there's a dog, there's a German Shepherd's dog. Okay. Now there are two dogs, and here I can put a main method once again, right? So now I can say there is a dog. I don't know what type of dog this is. Some dog, my dog equals new dog, and I can say German Shepherd dog. Uh, but first of all, I have to create an instance of German Shepherd. Let's call it GS for short. So new German Shepherd, right? So I have a normal dog and I have a German Shepherd dog. So I can say my dog dot bark and I can say German Shepherd dot bark, right? So now if I run this, once again I get two barking, right? So German Shepherd now barks exactly the same way as any dog because there's only one method. So if you go to dog, there is only one bark method, and this is how all dogs bark. Okay, barking like a normal dog. Let's put it like this. Okay, now I go to the German Shepherd class. I run this German Shepherd class. So both the dogs, German Shepherd and the normal dog, are barking like a normal dog. But I don't like this. I want my German Shepherd barks differently, right? So what I can do, I can simply override that in my German Shepherd's class, and instead of this, I can say barking like a German Shepherd, right? So now what will happen? See, the normal dog barks like a normal dog, and German Shepherd barks like a German Shepherd. Now, this is a natural way of looking at the world, right? So you have a dog. So in the real world, there is a dog. The dog can bark, right? So there's a class, there is an object, okay? But there is a German Shepherd, which is also a dog. German Shepherd, which is also a dog. Unless I say anything specific, it behaves like a normal dog. But if I say something specific, then it does that specifically. Okay. So that's what it is. For example, in dog, let's say I have another method, wag tail. Okay. Yes, so it is a keyboard shortcut. Wag tail like a normal dog. Okay. So so I have this method now, wag tail. In the German Shepherd case. So let's forget the normal dog now. We only have a German Shepherd. German Shepherd can bark. German Shepherd can backtick. Okay. Now German Shepherd barks like a German Shepherd, but it wags tail like any other dog because there is no special code written for German Shepherd. It extends from the parent, which is dog. See, barking like a German Shepherd, but wags tail like a normal dog. You see what I'm saying? So you can have a hierarchy. So you can say a dog, and then a German Shepherd, and then an Indian grown German Shepherd, a vegetarian Indian grown German Shepherd, and then you can have methods at appropriate places, right? And then you create instance of the Indian vegetarian German Shepherd, and then you call method on it, then you will get a specific behavior, right? So this is how Java uh, looks at coding. And that's why object oriented coding became so popular because writing code this way is a lot easier and a lot simpler than writing in your Python style, like putting everything in one class. And so of course, now you can do classes in Python also, but yeah, Java was original and native that way. Any other question? Okay. Um, we have another 10-15 minutes, so I'll tell you one story and then I'll stop. Uh, so, people, here is a question for you. Beauty and quality. Do you think these are subjective or are these objective? Raise your hand if you think it's highly subjective. What I think of as beauty is not necessarily need not be beautiful to you. It is subjective. If it is the case, raise your hand. Only Alekya thinks so. Okay. Now slowly the hands are coming. So okay. So for those who are not raising the hand, what they are saying is no. These are objective, meaning we both can train ourselves in such a way that I show a picture, both of us will say it's beautiful, or both of us say not beautiful. Okay. Then it becomes objective. Okay. So the question is, can we agree some things are beautiful and some things are not? So this was the central question. So here are two pictures. Who recognizes the building on the left? The curved entrance and some nice plants, white and red color painting, some glass doors. What building is this? All of you recognize, I'm sure. Yeah, so this is our beloved CMI. And on the right is one suburban area from Mumbai. This flat is probably some 15 plus years old, not so well maintained. So now let me ask this class, which do you think is more beautiful, the one on the left or one on the right? Raise your hand if you think the Mumbai suburb building is more beautiful than CMI. Nobody here? There should be at least one Mumbaikar in the class. No Mumbaikars here, is it? Most of the times I get at least one Mumbaikar who will still raise the hand saying, it's my Mumbai, Amchi Mumbai. So it is beautiful the way it is and all that. But yeah, so here it seems like at least for this particular question, we together agree that something is beautiful and something is not. So this question of can we agree some things are beautiful and some things are not seems like yes, it is possible. May not be in all cases, but in some cases. So this is where the story starts. It's a nice, beautiful story, very little story, 5 minute story. There was a person called Christopher Alexander. So Christopher Alexander was a researcher. He went to Berkeley for his PhD. So he had this question: what is a good design? Okay, and then the specific question: are beauty and quality objective? Right. So this was the question. So people, there are many of you who might want to do a PhD. So my advice to you is you should do a PhD when you have a question that bugs you like this. So there is a question for your life. Okay. You really want to find an answer. And that answer you want to run around the world and tell everybody, hey, look, I found this answer. You must know this answer. If you know this answer, your life will be different. The world will be different. So if you get such a question whose answer is so exciting to share to the entire world, that is when you should do a or you should join a PhD program. That's the right way of looking at PhD. Okay. Anyway, now coming back. Um, so Christopher Alexander had this bugging question: beauty and quality are the objective of not. So he dropped everything. He went to Berkeley and he wanted to study this. And he asked this from an architectural perspective. I mean, building construction perspective. Okay, not software development. So the PhD brain takes you from one question to other to other to other, right? And then when you have answered a bulk of other questions, you might have answered the original question. So this led to the second question, which is what makes a good architectural design? Now, of course, if you can answer this question, you can answer what makes a bad architectural design. Maybe sometimes it's easier to answer what is bad rather than what is good. Then one more question: can we recognize a good design? Um, and is there a basis for describing common consensus? Right. So at the outset, all of them look the same, but these are all very different questions, and they require different kinds of experiments to come to any meaningful answer. Finally, Christopher Alexander came up with this answer that beauty can be objectively measured. And as an example, he gave symmetry is considered as good. And there's a common consensus that all of us like symmetry. So, who can tell me? Now, question to the students: what is the most symmetrical structure you have ever seen in your life? Any God's creation, most or human creation, anything that is perfectly symmetric, most symmetric structure that you have seen in your life. Let's put it in your chat. I'm not talking about software or big data or distributed computing. Yeah, there's one answer. Taj Mahal. Every year, year after year, I get this as the first answer. I don't know how. I don't know why, but people think of Taj Mahal perfectly symmetrical structure. Uh, in the 2020 batch of yours was the most mischievous batch, I would say. Uh, they also said Taj Mahal, but after Taj Mahal they said Aishwarya Rai. I was like, what? But of course, yes, symmetrical structure. Why not? Um, Moon is not symmetric, no? Mike, I think Moon is not symmetric. It is slightly skewed. But yeah, from here at least, yes, we do see Moon as a symmetric structure. Uh, Human beings are, at least left and right, are symmetric mostly. So you have several such examples, but then yeah, Taj Mahal is probably the best example. Um, think of think of you being a Maruti. Okay, so you are coming up with a car. So how would it look like if you paint, if you divide the car into two sides, right? On the left full you paint red, and on the right you paint yellow. I mean, would you think you will like such a car, right? So this is an example where everyone has agreed that symmetry is good. If you paint red this side, that side should also be red. The entire car should be red, or entire car should be green or yellow or whatever. But don't have two such colors, then our people will not like it, right? So these are some things which we have come to apply in our designs. Uh, so this also takes us to this nice subject field of study called cultural anthropology, which says within a culture, individuals agree what is a good design and what is beautiful. So this reminds me, if you go to Japan, you're not supposed to write your name or anybody's name in a red pen. Do you know why? Why you should not write name in red? In general, we don't write names in red pen anywhere in any culture, but in Japan it is like quite obvious. Exactly. Vivek says that. So red signifies death. So that means that person is dead. Okay. So there are certain things which are considered bad to do. There are certain things which are considered good to do in some cultures. So this the study of cultural anthropology. So basically, what Christopher Alexander said was this: if you take good design structures, there are some similarities between them, and Alexander called these similarities as patterns. So there are patterns. Okay. A pattern, if I have to describe it, it's a solution to a problem in a specific context. But keeping this definition aside, in the words of Christopher Alexander, it is each pattern describes a problem which occurs over and over again in our environment, and then describes the core of the solution to the problem in such a way that you can use this solution a million times over. Okay, so one pattern is, as I said, have symmetry. Okay, so now this have symmetry is a solution to a problem of design, right? So when you are designing cars, how you should design, the solution is symmetry. If you have a light at this height on one car, On the other side, also keep the light at the same height. Don't keep one light here, one light here, right? So these are the kind of patterns, which is basically a solution to a problem in the context, that we human beings have kind of subconsciously learned. Okay, so um, yeah, so this I already asked, and you said Taj Mahal. Equivalent ideas exist in software also. Okay, so there are patterns that exist in software design also. Um, what are they, and how? What is a good design? What is a bad design? What could be the similarity between those designs? So that takes us to this new world of patterns. Um, so this is a start of a very nice and interesting topic. So let's stop here for today. In the next class, we'll jump into the world of patterns. Any questions? All right, then we are done. Thank you so much, and look forward to meeting you on first. All right.